Hello and welcome to Maths with Favor. Today we'll be talking about conversion from base 2 to base 10 and back. That is from conversion from base 10 to base 2. Or we could say from binary to decimal and back. So front and back. Okay, that is what we'll be doing today. Okay, I believe we know what binary is already, and decimal, binary base 10, decimal, binary base 2, decimal base 10. So let's go on. Okay, let's convert. Let's have an example. 1 0 1 0 1. Now we want to convert this to decimal. Okay, I want to convert it to decimal. So first of all, for us to do that, we'll look at this. We are counting in terms of 2. Yes, for the binary, we are making it in terms of 2's. So when we want to convert this to decimal, we'll say yes, under this 2 is to power 0, 2 is to power, 2 is to power 0, 2 is to power 1, 2 is to power 2, 2 is to power 3, 2 is to power 4. I believe you're with me. 2 is to power 0, 2 is to power 1, 2 is to power 2, 2 is to power 3, 2 is to power 4. So we'll start like this. So that is 1 times 2 raised to power 4 plus 0 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1. Then finally plus 1 times 2 raised to power 0. Yes, that's correct. So we have in here to be equals to 1 times, that will be 1 times 2 raised to power 4 should be 16. Yes, that's 16 plus 0 times 2 raised to power 3 is 8 plus 1 2 raised to power 2 is 4. Yes, 4 plus 0 times 2 raised to power 1 is 2 plus 1 times 2 raised to power 0 is 1. Okay, so we'll be having 1 times 16 is 16, 0 times 8 is 0, 1 times 4, that is plus 4, plus 0 times 2, 0, plus 1 times 1, that is 1. So here we have 16 plus 0, still 16 plus 4, that is 20 plus 0, still 20 plus 1 equals to 21. So we can say 1 0 1 0 1, that is base 2 equals to 21 base 10. I believe you got that. So we'll be dealing with another example. So let's try 1 1 1 0 1 1. I believe we should try this. So as we're counting in terms of 2's, we're counting in terms of 2's. So we say 2 raised to power 0. Okay. 2 raised to power 1. 2 raised to power 2. 2 raised to power 3. 2 raised to power 4. 2 raised to power 5. Okay. Are you with me? So we do it like this. So 1 times 2 raised to power 5 plus 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Okay, I believe you're with me. So we say equals to 1 times 32. Yes, 2 raised to power 5 is 32. Then plus 1 times 16 plus 1 times 8 plus 0 times 4, okay, plus 1 times 2, okay, plus 1 times 1. Alright, so we have 1 times 32 is 32 plus 1 times 16 is 16 plus 1 times 8 is 8 plus 0, okay, 0 times 4 is 0 plus 2 plus 1. So we have 32 plus 16. Okay, this is 32 plus 8, that is 40 plus 16, which is 56 plus 2 plus 1, that is equals to 59. I believe I'm correct. So thus we can say 1 1 1 0 1 1 base 2 equals to 59 base 10. Yes, that's correct. Okay, now we are considering conversion from decimal to binary. So we'll be working on what we have previously worked on, is 21 and 59. So let's start with conversion from base 10 of the number 21. Okay, so this is what we do. 21. You're making use of long division using 2. Long division using 2. So we say 2 divided by 21. 2 divided by 21 will have 10. Okay, let's make use of a calculator. Let me make use of my calculator and show you how you can do it. So we have something like this. We have 21. So we say 21, sorry, not 2 divided. 21 divided by 2, we're going to be having 10.5. So you write the 10. This 0.5 is the remainder, or rather, to get the remainder. Okay, we got 10.5. Are you with me? So we have written the 10. So we'll say minus 10. Minus 10 is half. But we can't write remainder 0.5. No. So we'll say times 2 to get our remainder. I hope I'm not complicated. Making it complicated, remainder 1. Let me go over that again. So 21 divided by 2, we will get 10. 10.5. So all we will do is to write out this 10, the numbers before the decimal point. Then now we want to find what will be the remainder, because 10 times 2 is 20. So it's just like saying 10 times 2, 20. 21 minus 20 is remainder 1. But if we are making use of our calculator, we can just say 10.5 minus 10, then which will give us 0.5 times 2, which is 1. Okay, so we say 2 again. 2 divided by 10. 2 divided by 10 will be 5. 10 divided by 2 is 5. there is no remainder, there is no decimal point, so that will be remainder 0. Remainder 0. So we say 5 divided by 2. 5 divided by 2 will be 2 remainder 1. 5 divided by 2, 2. Then we have, that is 2.5 minus minus 2 times 2. I don't know if you're getting me. So let me leave the calculator. So we have 2 divided by 2 will be 1 remainder 0. Then they will say 1 divided by 2 will be 0 remainder 1. Let me go over it again. 21 divided by 2 gave us 10, remainder 1. 10 divided by 2 gave us 5, remainder 0. 5 divided by 2 gave us 2, remainder 1. 2 divided by 2 give us 1, remainder 2 divided by 2 give us 1, remainder 0. 1 divided by 2 give us 0, remainder 1. So now at this point we'll do this. We draw an arrow. And what does this arrow signify? It signifies that we are counting from the downward, upward. We are writing our numbers from this upward. So okay, let me show you. So we have 2110 will be equals to 1 0 1 0 1 base 2, like we got in our previous answer. 1 0 1 0 1. Okay, I hope you're with me. Then let's go to 59, conversion of base 59 base 10 to base 2. Please be with me. Okay, so we are going to be having 59 divided by 2. We're going to be having 29 remainder 1. 59 divided by 2, 29, so remainder 1. So we're going to be having here to be 29 divided by 2. So this will be 14 remainder 1. So we have 2. So we have 14 divided by 2. That will be 7 remainder 0. Here we are having divided by 2 again. 7 divided by 2. That will be 3 remainder 1. 3 remainder 1. So 3 divided by 2 will be 1 remainder 1. Sorry. Yes, correct. So correct. Then 1 divided by 2. So we'll be having 0 remainder 1. Then we draw our arrow again, which signifies we are counting from the bottom upward. We are counting from the bottom upward. So that will be 59 base 10 equals to 1 1 1 0 1 1 base 2. I believe that correlates with our previous answers. 1 1 1 0 1 1 2, and this 1 0 1 0 1. So we can also use our calculator. I've showed this in my previous video. You can use your calculator to confirm. So we'll go to mode, go to base, then this is decimal. So we want to convert from 21 base 10 to binary base 2. So we have 21 21. So 10101. That is it. So let's convert 59 to base 10. So base 2, 59, 59, binary 111011. I believe we are correct. So that will be all for today in our conversion from base 10 to base 2 and base 2 to base 10. Thank you so much for watching. See you in my next video. Thank you. Please don't forget to like, subscribe, and share this video. Thank you.